Hello, welcome to the first video on your tutorials for the Mechanics 2 for OCR. This video will show you only question 1. There'll be more videos to come for future questions. Pause the videos at any point and just rewatch any bits that you don't quite follow. Okay, let's go straight into it. So for question 1, we have a cone on a inclined surface. We're told various bits about the cone, but the bit we're most interested in is that at a certain angle of inclination, it's the point of toppling. Okay, so this if it's toppling, it implies there's a moment going on to make it topple. It's not sliding down; it's twisting around a axis that's going to make it topple over. Okay, so this really means that there's going to be some kind of force up here that's large enough to make it topple over. Okay, and that's actually going to be its centres of mass. Okay, let's go straight into this. So just doing a very quick sketch of our cone first. Okay, so here's our cone. And we can, if we want to, get both of its centres of mass. So its centres of mass in the x direction, taking this corner here as a datum, is going to be equal to its radius because it has a line of symmetry just down here. Okay, I haven't drawn this very well, but hopefully you can see that. So its x bar will be just the radius. And actually, it turns out we're not going to really be interested too much into this, but it's worth writing down just in case. Okay, and if you look in your formula booklet, for the centre of mass in the y direction, it's actually just a quarter of the height for a solid cone like this. Okay, and we know the height is 20 centimetres. So the centre of mass in the y direction is 20 over 4 from the base, or simply 5 centimetres from the base. So up here somewhere, not drawn to scale. Okay, so this is going to be quite important for us. So at the point of toppling, the centre of mass is going to be directly over the base of my cone. So if I draw a very simplified diagram here, here is my centre of mass, and here is the edge of the cone, and then we can have something that looks like this. Okay, so here's the edge of my cone. It's going to be horizontally over the edge of my cone, and I know certain bits about the centre of mass. I know the centre of mass vertically downwards is going to be the very centre of the circle here. So I know this distance here is going to be 5 centimetres from the very bottom of my cone. And I know from the edge of the cone to the centre is also the radius. Okay, so if I draw a little horizontal line here, I know that the radius makes an angle to the horizontal of 24 degrees, I believe. Yep, 24 degrees. And I know this is horizontally down, so I've got a right angle here. So if you want, this is going to be 66 degrees. This is the right angle. And so this is also 24 degrees. Okay, so now I have one of these two angles. I don't need both of them, but one of them is going to be useful. I'm going to be using this one primarily because it has a nice link to our angle to the horizontal. So I'm going to use this angle, and I know a distance, so from here I can find another distance. So I can say the radius is equal to tan 24. So putting that into a calculator, you should get this to be 2.23 centimetres to 3 decimal places. 3 SF even. Okay, and that's that question done. Now for part 2, fortunately for us, it's not too dissimilar. So if we look at question 2, we're being asked if a different cone with the same vertical height but with a different base will topple at 24 degrees. Okay, now it's only worth 1 mark. You can do this a variety of different ways, but I like to just take a little bit of extra time with it just to make absolutely mathematically sure that this makes sense. So I'm going to just use the same model that I had earlier, but this time I'm going to find out what angle my cone will topple if it has a radius of 2.5 centimeters. So at 2.5 centimeters, the height hasn't changed, so this direction hasn't changed either. This is still going to be 5 centimeters. Sorry about that. We want this angle, which is the same as the angle to the horizontal. Now we're just going to basically see what angle this will topple at. So we want this angle here. So at this time we can just say that tan alpha is equal to 2.5 over 5. So using inverse tan, the angle at which this particular cone will topple will be 26.6 degrees. And clearly this is smaller than 24, so our cone will not topple. So cone will not topple as alpha is less than 24 degrees. Okay, and this guarantees our mark because we've been very mathematical about that. Okay, I hope this helps. There will be future videos for extra questions. Do make sure you have a look at those if you need them. Thank you very much.